Hello everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. Hopefully you're all having an awesome day today, ready to learn something. Today's video, we are back again inside of TryHackMe. This is the Cybersecurity 101 learning path. This is the web hacking module. This is the web application basics room. Learn the basics of web applications, HTTP, URLs, request methods, response codes, and headers. So let's go ahead and dive into it. Task 1, Introduction. Let's take a look here. Introduction. Welcome to the Web Application Basics. In this room, we'll walk through the key elements of a web application, such as URLs, HTTP requests and responses. This is perfect if you're starting and want to get a handle on the essentials of, or if you're looking to build or work with web apps. Learning objectives. By completing this room, you will understand what a web application is and how it runs in a web browser. Break down the components of a URL and see how it helps access web resources. Learn how HTTP requests and responses work. Get familiar with the different types of HTTP request methods. Understand what different HTTP response codes mean. Check out how HTTP headers work and why they matter for security. All right, I'm ready to learn about web applications. And task number 2, web application overview. Consider an analogy of a web application as a planet. Astronauts travel to the planet to explore its surface, similar to how someone uses a web browser to explore or browse a web application. Although we only see the surface of a planet, a lot is going on under the surface. You can imagine the whole planet as a web server with many things going on under the surface of the web browser, yet all we can usually see is the surface of web pages or apps. We will now explore the various components that make up a web application. Front end. The front end can be considered similar to the surface of the planet, the parts that an astronaut can see and interact with based on the laws of nature. A web application would have a user interact with it and use a number of technologies such as HTML, CSS, and JavaScript to do this. HTML, Hypertext Markup Language, is a foundational aspect of web applications. It is a set of instructions or code that instructs a web browser on what to display and how to display it. It could be compared to simple organisms living on the planet. These organisms have DNA, which is the instructions for how simple organisms are put together. CSS, Cascading Style Sheets, in web applications describes a standard appearance such as certain colors, types of text, and layouts. Continuing the analogy with DNA, these could be compared to parts of DNA that describe the color, shape, size, and texture of the simple organism. JS, which is JavaScript, is part of a web application front end that enables more complex activity in the web browser. Whereas HTML can be considered a simple set of instructions on what to display, JavaScript is a more advanced set of instructions that allows choices and decisions to be made on what to display. In the planet analogy, JavaScript can be considered the brain of an advanced organism, which allows decisions to be made based on what and how something interacts with it. The back end of a web application is things you don't see within a web browser, but are important for the web application to work. On a planet, these are the non-visual things, the structure that keep a building standing, the air and the gravity that keeps feet on the ground. A database is where information can be stored, modified, and retrieved. A web application may want to store and retrieve information about a visitor's preferences on what to show or not. This would be stored in a database. A planet may have more advanced inhabitants who store information about locations and maps, write notes in a diary, or put books in a library and files in a filing cabinet. There are many other infrastructure components underpinning web applications, such as web servers, application servers, storage, various networking devices, and other software that support the web application. On a planet, these are the roads that are present, the cars that run on those roads, the fuel that powers the cars. WAF, Web Application Firewall, is an optional component of web applications. It helps filter out dangerous requests away from the web server and provides an element of protection. This could be considered similar to how a planet's atmosphere can protect inhabitants from harmful UV rays. Summary: there are many components involved in delivering a web application. Front-end components like HTML, CSS, and JavaScript focus on the experience inside the browser. Back-end components such as web browser, database, or WAF are the engine under the surface that enable the web application to function. This simple introduction will be built upon in the upcoming tasks. Okay, question time. Which component on a computer is responsible for hosting and delivering content for web applications? Well, that's going to be web server, as we saw up above here. All right, we were talking about all the components here. Where is that? That should be right there, such as web service, application storage, yada, yada, yada. Okay, let's talk about infrastructure components. Which tool is used to access and interact with web applications? That's going to be the web browser. And that was discussed in the front end somewhere, I'm sure. Yes, web application would have a interface, interact with it, etc., etc. Okay, let's see. Yes, right here. Similar to how someone uses a web browser to explore or browse a web application. So there's that one, and then which component acts as a protective layer, filtering incoming traffic to block malicious attacks and ensuring the security of the web application? Well, that's the web application firewall, as we can see right here, where it talks about that. Next item is going to be task number 3, uniform resource locator. All right, uniform resource locator. A uniform resource locator URL is a web address that lets you access all kinds of online content, whether it's a web page, a video, a photo, or other media. It guides you or guides your browser to the right place on the internet. Anatomy of a URL. They got the scheme, which is pointing to the HTTP user, host domain, port, path, query string, and fragment. Think of a URL as being made up of several parts, each playing a different role in helping you find the right resource. Understanding how these parts fit together is important for browsing the web, developing web applications, and even troubleshooting problems. Here's a breakdown of the key component scheme. The scheme is the protocol used to access the website. The most common are HTTP, which is Hypertext Transfer Protocol, and HTTPS, which is the secure form of that. HTTPS is more secure because it encrypts the connection, which is why browsers and cybersecurity experts recommend it. Websites often enforce HTTPS for added protection. User. Some URLs can include a user's login credentials or details, usually a username, for sites that require authentication. This happens mostly in the URLs and in URLs that need credentials to access certain resources. However, it's rare nowadays because putting login details in the URL isn't very safe. It can expose sensitive information, which is a security risk. Host/domain. The host or domain is the most important part of the URL because it tells you which website you're accessing. Every domain name has to be unique and is registered through domain registrars for a security standpoint. From a security standpoint, look for domain names that appear almost like real ones, but have small differences. This is called typo squatting. These fake domains are often used in phishing attacks to trick people into giving up sensitive information. Port. The port number helps direct your browser to the right service on the web server. It's like telling the server which doorway to use for communication. Port numbers range from 1 to 65,535, but the most common are 80 for HTTP and 443 for HTTPS. Path. The path points to the specific file or page on the server that you're trying to access. It's like a roadmap that shows the browser where to go. Websites need to secure these paths to make sure only authorized users can access sensitive resources. Query string. The query string is the part of the URL that starts with a question mark. It's often used for things like search terms or form inputs. Since users can modify these query strings, it's important to handle them securely to prevent attacks like injections, where malicious code could be added. Fragment. The fragment starts with a hash symbol and helps point to a specific section of a web page, like jumping directly to a particular heading or table. Users can modify this too. So like with query strings, it's important to check and clean up any data here to avoid issues like injection attacks. Awesome. All right, question time. Which protocol provides encrypted communication to ensure secure data transmission between a web browser and a web server? Well, that's HTTPS, as we saw up here. All right, so HTTP is the insecure form, and HTTPS is the secure form of that. What term describes the practice of registering domain names that are misspelt variations of popular websites to exploit user errors and potentially engage in fraudulent activity? That's going to be typo squatting, as we saw up here under the host domain section here. All right, you'll have those look-like domains. And the last one is, what part of a URL is used to pass additional information, such as search terms or form inputs to the web server? That's going to be the query string. Okay, as a setup here, you can modify that, and URL starts with a question mark. Okay, so it says that you can modify this and to look out for attacks like injection attacks, such activity like that. And let's talk about task number 4 here, HTTP messages. Okay, HTTP messages are packets of data exchanged between a user, the client, and the web server. These messages are very important for understanding how web applications work because they show how users' requests and the server's responses are communicated. Imagine an example of HTTP request and an HTTP response, where you can see key parts like the method, URL, headers, and status codes. These are what make the client-server interaction possible. There are two types of HTTP messages: HTTP requests sent by the user to trigger actions on the web application, HTTP responses sent by the server in response to the user's request. And you can see what they look like here. All right, this is sending a post request, okay, and the server responded with this, a 200 OK. Each message follows a specific format that helps both the user and the server communicate smoothly. Start line. The start line is like the introduction of the message. It tells you what kind of message is being sent, whether it's a request from the user or response from the server. This line also gives important details about how the message should be handled. Headers. Headers are made up of key value pairs that provide extra information about the HTTP message. They give instructions to both the client and the server handling the request or response. These headers cover all sorts of things like security, content types, and more, making sure everything goes smoothly in the communication. Empty line. The empty line is a little divider that separates the header from the body. It's essential because it shows where the headers stop and where the actual content of the message begins. Without this empty line, the message might get messed up and the client or server could misinterpret it, causing errors. The body. The body is where the actual data is stored. In request, the body might include data the user wants to send over to the server, like form data. In response, it's where the server puts the content that the server requested, like a web page or API data. Why understanding HTTP messages matters. These messages are the foundation of how web applications communicate. If they're structured properly, everything works smoothly. Knowing how they work will help you diagnose issues in web communication, which means better performance and reliability of your web application. It's also crucial for security. Understanding HTTP messages helps you implement strong security measures to protect data during transmission. Okay, let's take a look at these questions. Which HTTP message is returned by the web server after processing a client's request? That's going to be the HTTP response, right? As we were talking about up here. Okay, and we saw here in this graphic. And next question is, what follows the headers in a HTTP message? That's going to be the empty line. As it says here, empty line is a little divider that separates the header from the body. Okay, so that's it for that one. We're going to go on to task number 5 here. Hey everybody, welcome back to my channel. Be sure to hit the like button, comment, and subscribe. Once you subscribe, be sure to hit that notification bell. All right, so you know every time I post a new video. As you can see here, most people that view my videos, view my channel, are not subscribed. Now, if you do subscribe, it will help me get into the YouTube algorithm so that we can continue to grow our glorious community here. As always, thank you all for taking the time to watch. Have a nice day and enjoy the video. Task 5, HTTP request line and methods. An HTTP request is what a user sends to a web server to interact with a web application and make something happen. Since these requests are often the first point of contact between the user and the web server, knowing how they work is super important, especially if you're into cybersecurity. And they have a image here you can take a look at here, HTTP method, path, HTTP version, you got the header information here, HTTP values, okay? And let's close out of this. Imagine an HTTP request showing the key parts like The method examples would be get or post. Path examples would be / login, and version example would be HTTP / 1.1. These elements make up the basics of how a client, which is the user, communicates with a server. Request line. The request line or start line is the first line or the first part of an HTTP request and tells the server what kind of request it's dealing with. It has three main parts: HTTP method, the URL path, and the HTTP version. Example is this: method, path, HTTP, and then version. HTTP methods. The HTTP method tells the server what action the user wants to perform on the resource identified by the URL path. Here are some of the most common methods and their possible security issue. Get, used to fetch data from the server without making any changes. Reminder, make sure you're only exposing data that the user is allowed to see. Avoid putting sensitive info like tokens or passwords in GET requests since they can show up as plain text. Post sends data to the server, usually to create or update something. Reminder, always validate and clean the input to avoid attacks such as SQL injection, which is SQL injection, or XSS, which is cross-site scripting. Put replaces or updates something on the server. Reminder, make sure the user is authorized to make changes before accepting the request. Delete, remove something from the server. Reminder, just like with put, make sure only authorized users can delete resources. Besides these common methods, there are a few others in specific cases. Patch updates part of a resource. It's useful for making small changes without replacing the whole thing, but always validate the data to avoid inconsistencies. Head works like get, but only retrieves headers, not the full content. It's handy for checking metadata without downloading the full response. Options tells you what methods are available for a specific resource, helping clients understand what they can do with the server. Trace, similar to options, it shows which methods are allowed, often for debugging. Many servers disable it for security reasons, and I've used all these when testing out web applications like bug bounties and stuff like that. You use these in like fuzzing attempts and stuff like that. Connect, used to create a secure connection like for HTTPS. It's not as common, but is critical for encrypted communication. Each of these methods has its own set of security rules. For example, patch requests should be validated to avoid inconsistencies, and options and trace should be turned off if not needed to avoid possible security risks. URL path. The URL path tells the server where to find the resource the user is asking for. For example, in the URL https tryhackme.com API users 123, the path API users 123 identifies a specific user. Attackers often try to manipulate the URL path to exploit vulnerabilities, so it's crucial to validate the URL path to prevent unauthorized access, sanitize the path to avoid injection attacks, protect sensitive data by conducting privacy and risk assessments. Follow these practices Following these practices helps protect your web application from common attacks. HTTP version. The HTTP version shows the protocol version used to communicate between the client and server. Here's a quick rundown of the most common ones. HTTP.9, the first version, only supported GET request. 1.0 added headers and better support for different types of connect or content, improving caching, etc., etc. You can see the rest here. Goes on to talk about HTTP 3, built on HTTP 2, but uses a new protocol quick for quicker and more secure connections. Although HTTP 2 and 3 offer better speed and security, many systems still use 1.1 because it's well supported and works with most existing setups. However, upgrading to HTTP 2 or 3 can provide significant performance and security improvements as more systems adopt them. All right, question time. Which HTTP protocol version became very widely adopted and remains the most commonly used version of web communication, known for introducing features like persistent connections and chunked transfer encoding? That's going to be 1.1. So if you go back up here and read that, brought persistent connections, etc., etc. Which HTTP request method describes the communication options for the target resource, allowing clients to determine which HTTP methods are supported by the web server? That's going to be the option. So if you go back up here, you can see that here it tells you what methods are available for a specific resource, etc., etc. And last one, in a HTTP request, which component specifies the specific resource or endpoint on this web server that the client is requesting, typically appearing after the domain name and the URL. That's going to be the URL path, as we already discussed up here. All right, and right, so HTTP method, URL path, HTTP version, etc., etc. Okay, then it goes on to talk about the URL path in this area here. So let's go ahead and continue on to task number 6, HTTP request headers and body. Request headers. Request headers allow extra information to be conveyed to the web server about the request. Some common headers are as follows. Common request headers, you got host, user agent, refer, cookie, and content type. So be sure to pause the video and look through these, understand what they're talking about here. Request body, an HTTP request, such as post input, where data is sent to the web server, as opposed to requested from the web server. The data is located inside the HTTP request body. The formatting of the data can take many forms, but some common ones are URL encoded, form data, JSON, or XML. URL encoded application / x www form URL encoded. A form or format where data is structured in pairs of key and value, where key equals value. Multiple pairs are separated by an ampersand or and symbol, such as key 1 equals value and key 2 equals value 2. Special characters are percent encoded. So here's an example of what that looks like here. Okay, form data, multi-part form data allows multiple data blocks to be sent where each block is separated by a boundary string. The boundary string is the defined header of the request itself. This type of formatting can be used to send binary data, such as when uploading files or images to a web server. And here's an example of that. It looks like here. You got boundary stuff here. All right. JSON, application JSON. In this format, the data can be sent using the JSON, which stands for JavaScript Object Notation Structure. Data is formatted in pairs of name, value. Multiple pairs are separated by commas, all contained within curly braces. And here's what they're talking about here. All right. You'll probably see this quite a bit when you're looking at APIs, as you can see here, depending on what they're using. XML, application XML. In XML formatting, data is structured inside labels called tags, which have an opening and closing. These labels can be nested within each other. You can see in the example below in the opening and closing of the tags to send details about a user called Alexandra. All right, you can see that down here. Question time. Which HTTP request header specifies the domain name of the web server to which the header is being sent? That's going to be the host. All right, so you can see that here in all these examples. All right, and it also talks about it up here. Let's see. What is the default content type for form submissions in an HTTP request where the data is encoded as key equals value pairs in a query string format? Well, that's going to be the application www form URL encoded, as we discussed up here. Okay. And the last one says, which part of an HTTP request contains additional information like host, user agent, and content type, guiding how the web server should process the request? That's going to be the request headers. Okay. So I was already talking about it up here. Request headers allow extra information to be conveyed to the web server about the request, etc., etc. All right. And that is it for this task. Task 7, HTTP response, status line, and status codes. So let's see what they're talking about here. When you interact with a web application, the server sends back an HTTP response to let you know whether your request was successful or something went wrong. These responses include a status code and a short explanation called the reason phase that gives insight into how the server handled your request. Status line. The first line in every HTTP response is called the status line. It gives you 3 key pieces of information. Number 1, HTTP version. This tells you which version of HTTP is being used. Number 2, status code, a 3-digit number showing the outcome of your request. And reason phase is number 3, a short message explaining the status code in human readable terms. Since we already covered HTTP versions in task 5, let's focus on the status codes in the reason phases here. Status codes and reason phrases. I kept saying phases, but okay, phrases. The status code is the number that tells you if request succeeded or failed, while the reason phrase explains what happened. These codes fall into 5 main categories: informational responses 100 to 199. These codes mean that the server has received part of the request and is waiting for the rest. It's a keep going signal. Successful responses 200 to 209. These codes mean everything worked as expected. The server processed the request and sent back the requested data. Redirected uh, messages 300 to 399. These codes tell you that the resource you requested has moved to a different location, usually providing the new URL. Client error messages 400 to 499. These codes indicate a problem with the request. Maybe the URL is wrong or you're missing some required info like authentication. I love 404 errors, by the way. Server error responses 500 to 599. These codes mean the server encountered an error while trying to fulfill the request. These are usually server-side issues and not the client's fault. Common status codes. Here are some of the most frequently seen status codes. 100, continue. The server got the first part of the request and is ready for the rest. 200, okay. The request was successful and the server sending back the requested resource. 301, moved permanently. The resource you're requesting has been permanently moved to a new URL. Or use the new URL for now on. 404, not found. The server couldn't find the resource at the given URL. Double check that you've got the right address. 500, internal server error. Another one of my favorites. Something went wrong on the server's end and it couldn't process your request. All right, question time. What part of an HTTP response provides the HTTP version, status code, and a brief explanation of the response's outcome? That's going to be the status line, as we can see up here. Talking about status line stuff here. Which category of HTTP response codes indicates that the web server encountered an internal issue or is unable to fulfill the client's request? Well, that's going to be the server error responses. This is talking about 500 errors, right? So here you go, right here, 500 to 599. Which HTTP status code indicates that the requested resource cannot be found on the server? 404 errors, as I said, was one of my favorites right here. Okay. And task number 8, HTTP response headers and body. Let's see what they're talking about here. Response headers. When a web server responds to an HTTP request, it includes HTTP response headers, which are basically key value pairs. These headers provide important info about the response and tell the client, usually the browser, how to handle it. Picture an example of an HTTP response with the headers highlighted. Key values like content type, content length, and date give us important details about the response the server sends back. And you can see that information here. Required response headers. Some response headers are crucial for making sure the HTTP response works properly. They provide essential info that both the client and server need to process everything correctly. Here are a few important ones. You got date. Example is here. Date Friday, 23rd August 2024. Then you got the time there. This header shows the exact date and time when the response was generated by the server. Content type. Here's an example here. It tells the client what kind of content it's getting, like whether it's HTML, JSON, or something else. It also includes the character set like UTF-8 to help the browser display it properly. Server Nginx, that's an example. This header shows what kind of server software is handling the request. It's good for debugging, but it can also reveal server information that might be useful for attackers, so many people remove or obscure this one. Other common response headers, besides the essential ones, there are other common headers that give additional instructions to the client or browser and help control how the response should be handled. You got set cookie, and this is an example here. This one sends cookies from the server to the client, which the client then stores and sends back with future requests To keep things secure, make sure cookies are set with the HTTP only flag so they can't be accessed by JavaScript, and the secure flag so they're only sent over HTTPS. Cache control. This header tells the client how long it can cache the response before checking with the server again. It can also prevent sensitive info from being cached if needed using no cache location. And it says this one's used in redirection 3xx responses. It tells the client where to go next if the resources has moved. If users can modify this header during requests, be careful to validate and sanitize it. Otherwise, you could end up with open redirect vulnerabilities where attackers can redirect users to harmful websites. Response body. The HTTP response body is where the actual data lives, things like HTML, JSON, images, etc., that the server sends back to the client to prevent injection attacks like cross-site scripting, XSS. Always sanitize and escape any data, especially user-generated content, before including it in the response. Which HTTP response header can reveal information about the web service software and version, potentially exposing it to security risk if not removed? That's going to be the server. All right, so remember it was talking about that up here. Nginx is just an example, but it could say like IIS, which is another web server. Um, which flag should be added to cookies in the set cookie HTTP response header to ensure they are only transmitted over HTTPS, protecting them from being exposed during unencrypted transmissions? That's going to be the secure. As we go back up here and talk about set cookie, all right, it says secure flag, so they're only sent over HTTPS. And the last one, which flag should be added to cookies in the set cookie HTTP response header to prevent them from being accessed via JavaScript, thereby enhancing security against cross-site scripting attacks? That's going to be the HTTP only, as specified up here. All right, HTTP only flag, so they can't be accessed by JavaScript. So let's continue on to task number 9. We're going to talk about security headers. Security headers. HTTP security headers help improve the overall security of the web application by providing mitigations against attacks like cross-site scripting, clickjacking, and others. We will now dig deeper into the following security headers. You got content security policy, CSP, strict transport security, HSTS, X content type options, refer policy. You can use a site like the following here, which is securityheaders.io, to analyze the security headers of any site. After the discussion in this task, you will hopefully have a better understanding of what it is reporting on. You got CSP. A CSP header is an additional security layer that can help mitigate against common attacks like cross-site scripting. Malicious code could be hosted on a separate website or domain and inject into the vulnerable website. A CSP provides a way for administrators to say what domains or sources are considered safe and provides a layer of mitigation to such attacks. With the header itself, you may see properties such as default dash source or script dash source defined and many more. Each of these give an option to an administrator to define at various levels of granularity what domains are allowed for what type of content. The use of self is a special keyword that reflects the same domain on which the website is hosted. Looking at an example CSP header. Content security policy, default source, self, script source, self, HTTP, CDN, TryHackMe.com, style, source, self. We see the use of default source, which specifies the default policy of self, which means only the current website, script source, which specifies the policy for where scripts can be loaded from, which is self along with scripts hosted on CDN, TryHackMe.com. Style source, which specifies the policy for where style CSS style sheets can be loaded from the current website, which is self. Strict transport security, HSTS. The HSTS header ensures that the web browsers will always connect over HTTPS. Let's look at an example HSTS, and you can see that here. Here's the breakdown of the example HSTS header by directive max age. This is the expiry time in seconds for the setting, include subdomains, and an optional setting that instructs the browser to also apply the setting to all subdomains. Uh, Preload. This optional setting allows the website to include or to be included in preload lists. Browsers can use preload lists to enforce HSTS before even having their first visit to a website. X content type options. The X content type options header can be used to instruct browsers not to guess the MIME time or of a resource, but only use the content type header. Here's an example, no sniff. Here's a breakdown of X content type option headers by directives, no sniff. This directive instructs the browser not to sniff or guess the MIME type. Refer policy. This header controls the amount of information sent to the destination web server when a user is redirected from the source web server, such as when they click a hyperlink. The header is available to allow a web administrator to control what information is shared. Here are some examples of the refer policy. You got no refer, same origin, and strict origin when cross origin. Here's a breakdown of the refer policy header directives. No refer. This completely disables any information being sent about the refer. Same origin. This policy will only send refer information when the destination is part of the same origin. This is helpful when you want refer information passed when hyperlinks are within the same website but not outside the external websites. Strict origin. This policy only sends the refer as the origin when the protocol stays the same. So a refer is sent when an HTTPS connection goes to another HTTPS connection. Strict origin when cross origin. This is similar to strict origin except for same origin request where it sends the full URL path in the origin header. And a content security policy configuration, which property can be set to define where scripts can be loaded from. That's going to be script dash source, as we saw way up here. Script dash source specifies the policy of where scripts can be loaded from. When configuring the strict transport security header to ensure that all subdomains of a website also use HTTPS, which directive should be included to apply to the security policy to both the main domains and its subdomains. That's going to be include subdomains, as we read about up here, include subdomains. Which HTTP header directive is used to prevent browsers from interpreting files as different MIME type that or than what it is specified by the server, thereby mitigating content type sniffing attacks. It's going to be no sniff, okay? And it was talking about that right here. All right, task number 10, practical task, making HTTP requests. And let's see what we're talking about here. Click the View Site button on the right to launch the static site in split view. This is an emulator for making demo HTTP requests using what you learned from this task above. Complete the questions below. In case the static site not visible, click the Show Split Screen button at the top of the page. So go ahead and try to figure this out yourself, then come back to the video and we will continue on. Okay, so let's go ahead and take a look here. And the first one says, what or make a GET request to API users. What is the flag? And it says tour guide. Would you like a guided tour to learn more about how to get started? Sure. Change your HTTP request method. Change your URL here. And click here to send your request. Update your GET and POST parameters here. Seems pretty straightforward. All right, so we need to send a GET request here. I'm going to copy this and paste it. So let's go ahead and click go. And we got a 200 OK. And here is the flag right there. And there's more information down here as well in the browser. So this is the view page source. Like that's what you would be. No, this is from this is something you would see in like burp, like the burp tool. You see something like this. Make a post request to this here API user 2 and update the country of Bob from UK to US. What is the flag? So let's go ahead and do that. Okay, user 2. First, let's go ahead and It says change it to post. Okay, and let's take a look here. All right, so it says Bob, and I don't know if we can modify this or not. No. Let's see here. Ah, there we go. All right, so let's take a look here at what this key would be, and assume it's going to be country. So let's go ahead and try that. Let's try this again. Okay, US. Save it. Proceed. Okay, there we go. Okay, so it's case sensitive apparently. I think the hint says that too. Yeah. So there's that one, and the last one says make a delete request to API user one. So it should be pretty straightforward. Change this to delete. Change this to one. Click go. There we go. Just delete a user. So that's the end for that one. And task number 11, we're going to wrap things up here with the conclusion. That's it. You have completed all the tasks. We hope you enjoyed learning about the elements that make up web applications. Hopefully you have learned a bit more about what components are involved in web applications. The structure of the Uniform Resource Locator, which is the URL. What are HTTP messages, requests, headers, and responses? The importance of security headers. Enjoy your next learning adventure. I'm ready to move forward and learn about web application security. And that's it, folks. If you found this video of value, found it educational, hit that like button. Subscribe to the channel if you are new here. Share the video. Comment below your thoughts and opinions on the information shared in the video. As always, thank you all for taking the time to watch my video. Have a nice day, and I will see you later.